How much was vocab important on the last couple days for you all? It was. At least I hope it was. Just check one more thing. Okay, here we go. So what is concavity? What is a point of inflection? These are things that you are responsible for your work today and tomorrow. Okay? So we have 3.4a today, more of the intro, and then 3.4b. Here we go. 3.4, all about concavity. You guys were doing convex polygons in geometry? Concave, convex, okay? So, not really much, just that word was okay. Concavity and the second derivative test. Before we do the second derivative test, let me remind you about what's called the first derivative test, okay? The first derivative test could be called pinned, okay? This is not mine, this is someone else. You know, remember Hody Hi and Heidi Ho? That was a little technique that, helped me. The same people who did that one did pin, okay? Basically positive, increasing. Okay. What do you think this one is? Negative, decreasing, okay? So when I critiqued your answers when you gave your homework a couple days ago and I said, hey, don't say up or down, right? Remember someone over here? Not just you. Some of you guys didn't even say up or down. You just gave me intervals, right? So if you say up or down, well, that means something different today. So the first derivative test means if, okay, obviously, the first derivative is positive, your function is increasing. If your first derivative is negative, then your function is decreasing. That's going to be different for what the second derivative test tells us. Before we get there, we got to talk about concavity, okay? So how do I want you guys to see this here? Yeah, how about the graph of y equals x squared, okay? And you guys talked about the intervals of increasing and decreasing. Max and min, well, at least we have a min, right? What's true about the slope of this line at this tangent spot right there? What's true about that number? Take a guess. Is it steep or is it pretty level? It's a big negative number, right? What's happening over here? Right? What's happening over here? Each of these tangent lines, are they getting more steeper or less steeper, right? So when we say less steeper, especially what happened here, right? That means critical numbers, right? And then what happens is you keep going now. Now what's true about the tangent line? Maybe like 1/2, right? What's true about the slope right here now? 3-ish, maybe? What's happening way over here? So we're talking about the slope of the slope. We're talking about the rate of change of the rate of change. Welcome to the double or second derivative. The second derivative, basically how your first derivative, okay? How your slopes are changing. And again, that word is all about calculus, guys. The mathematics of change is calculus. So how your slopes are changing. If your slopes are increasing, right? Guys, is the slope number increasing? We call this, guys, concave or up. And what I want you guys to also realize is that every time your tangent line, notice that your tangent lines, are they below or are they above that red function? The tangent lines are always above or below? Below. Okay, I've seen that also given as definition. Okay, so let's take a look at a negative or concave down look to it. Okay, when we first start on the left-hand side, what's our slopes? Okay, what's happening though as we get closer here? We approach 0, and then from now on, our slope values are decreasing. So we call this one, guys, concave down. So please don't tell me, if you tell me up or down, I'm assuming you mean concave up and concave down. Again, this is the second derivative that we're talking about. And again, this time around, is our Brown function above or below those tangent lines? Okay? And so I've seen that both ways. And so please be ready to talk to me about those things. Now, parabolas are pretty simple, right? Do you think that a linear equation has concavity?
No.
Because what's true about y equals 4x? The derivative is always 4. Is the slope changing?
No.
No. So that's really a silly question. Okay. Again, we determine maxes and mins pretty easily by setting the first derivative to equal 0 undefined. Do we use endpoints? Not on relative extrema, but on absolute. And only those endpoints, right? And the critical numbers. All right, I'm done making fun of you, I think. All right. So what I want you guys to see here is, if you have something like this, do we actually have changes in concavity?
No.
And this is where your graphing calculator is not helpful. Are you all set? Thank you so much. Okay. Your graphing calculator is not really that awesome to help you to say exactly where it was. Let's face it. On your quiz a couple days ago, could you just done left bound, right bound? Guess your favorite number, right? I didn't tell you that, but I mean, you could have, okay? Over here, it's a much different story. But would you guys agree that somewhere around here, it actually starts changing, because you have a negative parabola up to about, who knows, maybe right there, so? And then from there over, you have a positive, right? And again, we're only seeing where the slopes are increasing or decreasing. Literally, if you want to see it, which I don't mind if you do, as long as it's differentiable, the graph of f is concave up. If f prime is, would that make sense? As long as the first derivative is increasing in value, it's called concave up. If the concave downward means the first derivative is decreasing, okay? And so you can see some blue lines. There's some lovely blue lines here. Again, blue tangent lines are below. That means concave up. Okay, see right here. The graph of left lies above the tangent lines. That's a good thing to check visually if you have a good memory of vocab. And notice here how we have intervals, don't we? Do we have concave downward on the open interval from such and such to such and such? Have you ever had a question like that before? Will you have a question like that again? Yes. So ready? Let's talk about concavity. So 1/3 x cubed f of x. Here we go, guys. F of x is 1/3 x cubed minus x, or x squared, just x. Okay, what I want you guys to do is tell me the intervals for concave up, concave up, or concave down. Could you do it increasing, decreasing? Could you see how your next test, you could probably do both for the same one question? Welcome to 3.6, okay? So the first derivative is what? Hopefully these numbers. So x squared minus 1, okay? Now, instead of finding the critical numbers of the first derivative, we're going to find the critical numbers of the second derivative, right? And so what do we have here? So the derivative f double prime, what then? And that equals 0, only when. So do we have only one critical number? So now negative infinity to 0, 0 to infinity. Okay, now these numbers that we're going to test, do they go into the original function? No, that would be for which one? Absolute extrema. Are these numbers going to go into f prime? No, that would be for intervals of increasing, decreasing. Guys, these test values are going to be taken to the second derivative, okay? So the second derivative of these, so what's f double prime of negative 1? Negative. And f double prime of 1? Which means, on your answer today, this is what you guys tell me. Concave down from negative infinity to 0. Concave up from 0 to infinity. Okay? As long as I have the word concave, I will understand. You know what? If you just say down, up, what am I going to default think of? Concavity. Okay? So make sure you guys can understand concavity. Oh, I need a parenthesis there, don't I? Okay? So is there somewhere where it changes the concaveness? Yeah. And look at the picture, because this one's kind of messy. All right? Again, the test, I think, makes sense, but can I share with you once here? If f double prime is greater than 0, what does it say here, guys? If f double prime is positive, then your interval is what? Concave. Would that make sense? If f double prime is negative, we would say it's concave down. Now, here's a silly slide of notes. Please, write this down, it'll help you, okay? I want you guys to put a plus sign and a plus sign and put a smiley face. Okay? Here's the phrase, guys. Concave up. Pass the cup. Okay? Coffee mug or something? Okay? Why do you think I have 2 plus signs? Because the double derivative being positive. You like that for you? Is that pretty good? Concave up past the cup. And now, conversely, or contrapositively, or inversely. Ready? Okay? What do you guys think? Concave down. Yeah, why the frown? Close. Minus half. All right. Stereotypical Asian person? Okay. So guys, sorry, I have to say that just once, okay? It's good. We're good. We're all friends. Okay. Guys, here we go. So, concave up, past the cup. Concave down, why the frown? Okay? Again, the double derivative means you're actually going to be concave down. Now, this is going to be interesting, though. I'll give you guys a little head start here. These parabolas, does this have a max or a min? Right, and this has a min. Now, this is kind of backwards, right? If you're concave up, you're going to have a local relative. If you're going concave up, you're going to have a relative min. That's kind of backward, isn't it? So a concave down is going to give you a relative. And we'll do that again when we have to go back to first derivative, okay? So looking at the graph, guys, take a look at the graph of example 1. Again, could you guys tell me intervals of concavity? Well, that means you do what? First derivative, which already are we talking quotient rule? Well, I guess they kind of sneakies. Okay? I guess we could survive by using product rule if you wanted to save a little bit of time, okay? But are we kind of, forced to do a lovely double derivative using quotient rule, okay? And again, you're always going to set these to equal what 2 values? Equals 0 or, now is this thing ever undefined? Is it ever equal 0? Plus or minus 1. And then we bring out our sign charts. And do we have sign charts here? Yes, we do. So sign charts from -1 to 1. And over here you have plus, you have a minus, you have a plus. Look at the graph, guys, okay? Take a look at the graph here. Do you agree that from -infinity to about here is when you have concave up, past the cup? And then what happens from -1 to 1? You're going that downward frownward, right? So past the, you're going why the frown? And then from 1 over, it's going to keep doing concave up. Okay? So those are some pictures I want you guys to see. And can I make you guys do one more thing here before too late? Oh, yeah. Can we talk about that spot there? Okay? What's true about the tangent line here? Okay? What's true about that one? What's true about these purple tangent lines, guys? Are they getting bigger or smaller? Yeah, they're getting larger, right? Now, what happens here? Okay, what happens past that point? Remember, this is going concave up, right? Slopes are getting bigger. Now, what happens when you go concave down? Right? So, what happens is something really neat, though. That spot is special. And I'm really murdering the picture. So can I go over to the next page to show you what I'm trying to show you? Okay? The next page has a nice picture here. Even if it's not continuous, can it still have concavity? Will those be the places where you have to stop and restart your graph? Okay? Here we go. Here is something interesting that happens when you go from concave up to concave down. Your blue tangent lines actually go where? It goes through it. Okay, or it goes like that. Okay, those are both examples of a definition you guys need to know how to do here. Okay, guys, the bottom left-hand corner says a little note here. Okay, again, is this a problem in concavity? Does it change concavity from upward, slopes increasing? Now, slopes are decreasing. So does something happen at that point there? We have a very, very important word we call it. The concavity of F changes at a what? Point of inflection. Note that the graph crosses the tangent line at the point of inflection. Guys, write this down if you're taking good notes. Poi. Notes. Sorry, I was thinking poi. Poi, which is what? Point, plural, maybe, of inflection. Okay? Can you have a tonal inflection, right? Does that mean you kind of change it, right? But this is talking about concavity inflections. So basically when F double prime changes from concave up to concave down, or what? From, what do you think, guys? Concave down to concave up. No, if you're writing these, I want to make sure that Annabelle can make sure you know from concave up to concave down. From concave down to concave up. Now, this is important. Where are your points of inflection? Your points of inflection will only happen at what places? This blue box tells us, okay? Actually, the one above it will, okay? I think I changed, oh, here we go. Okay, so up a touch, right, up, we'll look at that question just a minute here. Oh, not that one. There we go. So, if x comma f of x is a what now? Point of inflection, then what happens? Either the double derivative would have to equal 0, or the double derivative would have to be what? Not exist. But is that the definition of an inflection point? No. What is the definition of an inflection point? I gotta go back and find it for you. Bottom of this page. It's a long paragraph, but we're gonna abbreviate it. Okay. Here it is. Points of inflection. Okay. Lots of stuff going on there. Everyone just touch there. Okay. Basically, what are we saying here? Open interval. Has that been a source of problems for some people? Open intervals. Not closed. Anyways, okay. Point of inflection if the what now? If the concavity, what does it say here? Changes from upward to downward or downward to upward. Okay? So, remember before how we had, remember that silly extra credit question about a critical number? That was a critical number, but it wasn't a max or a min. Right? What must be true for points of inflection? Points of inflection is when it changes from concave up to concave down, or concave down to concave up. Can I do 2 quick examples of concavity, and I'll give you guys some time to work here. X to the 4th minus 4x cubed. Intervals and poi, okay? If I just say poi, then you just got to do x numbers, right? Okay? If you give me ordered pairs, it's nice. You don't have to, I don't think, but anyway, so I asked you for intervals as well. Well, here we go. First derivative being what, guys? You should know this. 4x cubed minus, okay, second derivative. 12x squared. And that's going to equal 0 when x is what, 2 numbers? Take out 12x out, right? So 0 and 2, is that right? Or 0 and 1? 0 and 2, right? Yeah, because it's 12x, x minus 2. So we have 2 critical numbers. Does this thing ever equal undefined? No, you're in good shape. Negative infinity to 0, 0 to 2, to infinity. And again, plug in test points that are going to be put in the double derivative, which, I don't know if you guys remember my way of doing it before, okay? Would you guys agree that negative times negative equals positive? And positive times positive equals positive? And that they're different signs, that they multiply and make a negative. You guys remember this? Did I do this with you guys last time? Okay, when x is negative 1, what's this become? Negative. What does this become? What's negative times negative? Right? 12 times 1? 1 minus 2. And then when you multiply, you make them negative. 12 times 3, 3 minus 2. So do we have concave up, concave down, concave up? And then, guys, do we have a change of concavity? Poi would be where? At x is 0 and 2. Because from the left, is it concave up? Does it change to down at x is 0? And does it change from concave down to concave up at the point when x is 2? Okay? Now, what I want you guys to see is you can also do this question using intervals. Increasing or decreasing, which right now I won't do, but we could when I had time for it, okay? Like tomorrow. Look, here's a picture. Don't expect to have this picture on your test, okay? AKA non-calculator. But do you guys see how you start concave up, and then you start concave down, and then you start concave up. Even if you have your calculator, is it going to tell you exactly where that point is? No, that's on you to figure out, okay? Can I do a silly one? Y equals x to the 4. Find me the points of intersection. Inflection, sorry, that's it. This is it, okay? And we'll do a second derivative test tomorrow. All right, so what's the first derivative? 4x cubed, fine. Second derivative being equals 0 when x is 0. Okay, so infinity to 0, 0 to infinity. What do you guys notice about this? They're both what? So is 0 a critical number?
Yes.
Sure, of the double derivative. But is it a point of inflection? Why not?
Because it doesn't change.
Okay, take a look at the graph. Guys, always go back to the graph when we were practicing this for the first time. Is this x to the 4? It looks like a parabola, doesn't it? It just looks a little more rounded right here. Okay? So concave up, 0, nothing's happening. Concave up, concave up. And notice how this question is not a point of inflection. Okay? So there you go. All right, I will give you a set apart of questions here. And I want you guys to use the 20 minutes, okay? And I want you guys to